Welcome back to TRCD Retro Programming. I am happy to say that um, my new game, Ulysses, is coming together well, and it's a little mishmashed right now. But I've put in a good number of hours lately trying to get the disk structure right, and so let's just list that. So I've been working to get the disk structure correct and also the coding sequence. And we're going to explore that a little bit in this video. So the first file is the game runner, the file that it's the file that contains the instructions for the game. It's a basic file. Um, I'm not a machine language programmer. I wish I was, but I'm just a hobbyist, and I don't have the need to learn machine language. It's not something that I need to know how to do right now. So, and we look at the granule on the right. It's only 2 right now granules on the disk. So if I list my free space, and I'm not getting too far ahead here, I hope, I still have plenty of space left on the drive. And so the next file is a data file, and that contains all the directions for the sprites. And that would be Ulysses, the figures that I drew up, that I use as the sprites. There's a bunch of them. They're all packed into this data file. And that's only 1 granule, and we're going to get into why I did that in a minute. And then I have 2 bin files. The first one is called running head. And what that means is when I run the game, it's the top half of the screen that contains the score, the level, the life, the magic, and the game title graphics. And then I have file 0, which is the training hall graphics, and any of you that are following this have seen me play that, and it's not finished yet, but that's the target shoot and everything like that. So those are the graphics that go on the bottom of the screen, and I've made some changes to that as well. So now a lot of people say, well, use get input, it's faster, this and that. I just don't use it anymore. The only time I use get input is when I have to do something quickly, or in a scenario where it needs to be done, because it doesn't always need to be done. So I draw all of my sprites using the draw command in strings. And any of you that have been following me for the past 1.5 years or so know that I only use string data in my games now. And what that does is it just draws the sprite on the screen, and it p copies it over to another screen and back and forth and everything, and you get your sprites that way. And it is very slow. Especially since I have big sprites and everything, but it's a slow computer. The last thing I'm looking for right now is speed. I'm more interested in accuracy. So, and the other reason I did this is to reduce. Now we're going to load Ulysses, okay? And if I print the memory, I have about 11.5K, and that's with nothing loaded. So I was dropping below this, far below this, and in order to make up, to regain memory, I needed to port the sprites out to a data file to get rid of all the repetitive strings. And I also binned out the graphics to get memory back. And now I'm up to almost 12K. So I've only used about 10.5K. And I mean, that's a lot for this. I have more than half left, or about exactly half left. So I did this to the bin files. We already know that now you don't have to have all these graphics commands, and it gets memory back. And the same with the sprite data. But that's not the only reason. The other reason, besides gaining memory back, which is a big reason, but the other reason is for portability. So, by portability, I mean we want to have a basic program in only one which controls the game, and we want everything else on disk, either in data files or bin files, for portability's sake, because I'm reusing these sprites on future levels, and I don't want to have repetitive coding in the list, which is going to reduce memory. And also accessibility. It's much easier to access a data file in bin files than having all of this garbage taking your memory away and slowing your program down. It speeds it up when you can reach into a bin file instantaneously or a data file. So it's actually increasing speed, increasing memory, and increasing accessibility and portability. So let me run the program real quick, and I'm not sure what's going to happen because um, it's all over the place right now. Parts work and parts don't work. So you just heard it load, and that was it loading its first sprite from that data file we just looked at, which is Ulysses standing to the right. Now when I hit the space bar, we get Ulysses shooting to the right, and those are the only two sprites that are saved in that data file. But within that data file, there are actually 5 strings, because this sprite here is broken up into 3 pieces. And the previous sprite is broken up into 2 pieces because there wasn't enough left on the line when you program, you can only have 8 lines. So this exceeded 8 lines 3 times, or 5 times. So we actually have 5 times 8, which is 48 lines, just to do these 2 poses. So I hit the spacebar again, and we simply just get an arrow. And so I left that in the basic program because I'm not going to bin out. I could, if I wanted to get picky, I could put this into the data file as well. But it's only 1 line, like a half a line. So I left that there. Now hit the spacebar again, and we pan out all of the numbers that are going to be used in the score. So these are going to be put into another data file called numbers. Right now they're taking up space in the program, but I'm not there yet. And so all the strings for these numbers are going to be in a data file. And right now it just prints them out 0 through 9. And that's going to make up the score font. Then I hit the spacebar again. And what actually happens is that we go back to We go back to the text screen or the program screen or whatever I don't know what it's called, just the text screen, the coding where you put your coding in, and it's testing the graphics capabilities of the score. And so we get a math function that you can't see, and then it pans it out here. So, for instance, the score is 1,200. I mean, the score is 12,345. If you look at it, it's just panning it out vertically. But it's just a dummy score that I put in there to make sure that the math function is functioning right. And we'll get into that. And I hit the space bar again, and now we go into the game. And for some reason now I don't have the graphics on the bottom. And I don't know why. They should be there, but they're not. So I'm gonna have to. It was working. When I do videos, this stuff happens all the time. I don't know why the bottom is not there. I'll look into that. But as you can see, I have an orange box over here which says score, and the score is supposed to go underneath there. It was there. It's not there now because I changed everything around. It'll be there. Over here is the level indicator in this box over here. And then up top will be the life bar in the spell bar. And let's break out of this right now because I want to know why the graphics aren't there. I have no idea. Yeah, the file is there. File 0 is there. So let's look at the list. If we start at the beginning, I have to clear 12,000 because it takes a lot of string space to input the data file. So when you can see that on line 10, this is when I start inputting the 5 data files that I just told you about. If you don't reserve enough space, it gives you an error, out of string space error. So then we do our sprite visual testing in the arrow, and then we go to the number strings, which are going to be put to a data file. Right now they're still in the coding, and then it draws them out, and then we get the math. And I want to go down farther into this file to see why, just why this is not working correctly here. And I already see that something's wrong with this code. Yeah, I must have not have saved it or something, because none of this is right here. Yeah, something's really screwy here. So it is here and it isn't here. So we didn't get the training room presentation or anything. So 126. Yeah, I don't know how this happened. I'm gonna have to put in 140, go to 126. I don't know why that's missing. I must have not have saved it. I must have listed it, but not saved it. I've been really tired today, and I don't know. let's look at this list again, and I'm gonna try to fix it, and then I'll have to correct it tomorrow. I can see it's faulty right after. None of this should be here. 61 through 85 shouldn't even be there. So yeah, this is not right. Let's delete 61 through 85. All right. And let's see, edit 87. This should be not go sub, it should be go to 126. Now that should solve the problem. Let's see what happens. I'm gonna go through all this really quickly. UL error in 60, list 60. What does that mean? A UL error in 60, list 61. Line doesn't exist anymore, so list 60 forward and edit 60 should be 86, then 86, not 61. Let's run this and see if this works now. Training room. There we go. Except for something's still wrong. Something's still wrong. It's in a loop here. List 128. List 126 forward. Let's see what's getting screwed up here. It should be it's not going to 126. It's going we got to edit line 40 and we got to make it go to the main game loop. 88, edit 140, go to main game loop. Now, I recommend that you label everything in your programs because this is why. You don't want to have a bunch of code and when you start debugging your game, you have no idea where anything points to. I label every little sequence so I know exactly where to go in the program to fix problems like this. So we get training room, and now it should go to the game screen, and that's it. And so, as you can see, I added some columns here. That's what those big purple things are. And for a lack of colors, this was the best that I could do. So those are two columns like holding up the ceiling, and it's a training hall, not a training room. It's kind of like an open cloister with some walls on the sides. So I might want to color these walls in, and he actually goes out through in between the columns, I guess. That's like open area outside, and this is the actual room or something. I just did the best that I could. The only place I used get input in this, and it's actually in a bin file now, is I got the column and placed it over here because I needed more than one. And I could make like 4 of them if I wanted to. So I only use get input where it's functionally necessary in graphics, like where you don't want to have to draw this whole thing all over again. But as far as the sprite movement, it's all being handled by draw statements. And it's not incredibly slow. It's a slow computer, and I don't know machine language, so this is the best I can do. I'm not worried about speed. I'm going to end the video here because that's all I really wanted to cover right now. And so the score should be here, but I changed the way it was structured, so I have to. The score will be right here. It was there, but it's not there now. Um, but I changed the structure of the program, so it's not there. But I'm gonna fix all this stuff. Uh, if I list like 150 forward, we take a look at the math here for the scorekeeper list 190 forward. So the math at it, let's try this again. I hate this. 190 to 197. This is actually, yeah, this is how the score is tallied. And I mean, if you take a look at this, it's a little overwhelming, but in order, like, when I have that dummy score 1, 2, 3, 4, 5, you see PTS equals 1, 2, 3, 4, 5. Then we have the math that controls that number. So in the game, the score is PTS. So you're going to start with 0. So for example, if I edit 191 and I change this to 0, 0, 0, 0, 0, and I run 191, we get 0, 0, 0, 0 instead of 1, 2, 3, 4. So that is going to be put into graphical terms, and it's just base 10, and that's how you're going to graphically control the score with the number strings. So if I run this and we get those numbers, now these are in graphical terms, so we have to be able to control these somehow to arrange them to keep track of the score, and they don't do that by themselves. So you have to have assignments for every list 192 to 197 or whatever it was. You have to have these assignments there to control those graphics. And so it's actually 193 to 198 for anybody that doesn't know this. And I just invented this. I'm sure there's other ways to do it, but they're not going to vary very much from this. You can't display graphical numbers on the graphics screen on a color computer 1 or 2, so you have to make your own font, number 1. And number 2, you have to have a way to control it. So what I did is I put S equals integer points divided by 10,000, and that will give me a 1-digit figure in the 10,000s place. And then S1 equals the same formula, but the actual points minus S times 10,000, which is this here, divided by 1,000, which puts us in the thousands place. And then we get our thousands place marker, and so on, all the way through hundreds, tens, and ones. And for every sequential next numbering of S, so we have S to the 4th. We start with S, 1, 2, 3, 4. That gives us 5 place values, and you have to keep changing the formula to include the previous S markers until you get all the way down to the ones place. So, having a background in math helps. which I do. So this didn't take me. I had done this earlier for another program, but it wasn't right. But I took that idea, I analyzed it, and I made it better, and I made it actually work the right way. Anyway, without further ado here, I'm going to cut this off. I thank you for joining. If anyone has any questions, feel free to ask. Other than that, I'll be back with a non-commentary update on this game as soon as it's functioning properly. Keeping score, for example, displaying the level that you're on, your life, and so forth. So I'll make updates, but they'll be non-commentary. And I thank you for watching, and take care. Bye.